We're here at Project Sophie in the great state of Kentucky. We've just energized this 25 megawatt facility, and I have our Chief Technology Officer here to tell me more about the history and background that culminated to this moment here. Dip, how you feeling?
Oh, I'm pumped, man. There's always something to do, but it's exciting, right? Because we've been designing this for a while, and we've always talked about it and had thoughts and ideas and aspirations, and now it's here, and we get to see it come to life, and it's awesome. Yeah. Super exciting, you know?
Tell us about some of the key design principles around this facility.
So I would say that the concept of modularity and being able to automate it and run it in a way that we could put the site anywhere in the world and it could be run by local people was a big piece. And then on the modularity piece, it was about being able to swap out different components, right? So we could go from one type of gear to another type really quickly. The power, the airflow, and everything kind of adapts around it really quickly. And so that gives us the most flexibility. And then the last piece is ultra efficiency, right? We want the most energy getting to the computer. So we don't want to waste energy on like even incandescent lighting or using air conditioning, things like that. So everything has been chosen to maximize the efficiency of the site, both from an operational side and an actual electronic side, which is fun.
And it also allows you to absorb as much of the renewable energy that's spilled as possible, I would imagine.
That's right. I mean, we're connected right here to the substation, which goes to a power dam, which is about 30 miles from here or so, and it's a hydroelectric dam. And what's amazing about this site and our architecture in general is you can scale its power based on what the grid has or what it doesn't have, right? So if it's the Super Bowl and everyone's at home partying, we can kill the data center to give more energy to the people. But then when everyone's asleep and there's a lot of excess, we can energize the site and consume the extra. And that's another piece of that modularity because the equipment, the network, the cooling, the operations are all designed in a way that enable that. You can't just kind of add that on layer.
Right,
right. Operational security, just so much has to be thought about when you want to actually take a site dark, and turn it off.
So if I'm an IPP, I've got a big wind farm or a big solar farm, and I'm experiencing high degrees of curtailment, otherwise known as wasted energy or spilled energy. How would a facility like this benefit my site?
Well, I mean, it's perfect, right? Because we can use any land that's around there. We could deploy very quickly, generate local jobs. But then on the most tactical and direct level, we eat all that extra power, right? So it no longer goes to waste. So all of your machine, on a very direct level, we eat the extra energy. On a little bit less direct level, your machines will operate more efficiently because they're not scaling the output. And it's like running a car at perfect idle, right? And so it enables the entire chain to become more stable, and when you bring stability to any system, it gets more efficient.
That's fantastic. Well, it's going to be exciting to see more of these facilities popping up all over the country.
I'm so excited, man. I'm pumped. We have a huge pipeline, and I love being in Kentucky. The food is great. The people are great. The weather's warmer than Boston, and so, Texas, I hear, is super hot, so I'm glad we're there in the winter, But yeah.
That's going to be great.
Fun.
Looking forward to doing this for more IPPs. And it's nice to see you, my friend.
You too, man. You too.